Okay, guys. Good morning to all.
Good morning, sir.
Good
Good
morning,
morning,
sir.
sir.
Good morning. Very good morning, guys. Very good
Sir, are
morning.
we doing
Yes, sir.
only science or are we starting math
Only
also?
science. Only science, beta. Only science.
Are you
We
still
will
in
do
eighth
only
chapter?
science.
Are you still in acid base chapter?
Yes, we were in the last of it. So today we'll start a new chapter also. So we will start today metal and non-metal, chapter number 27. We will start that also, but just will not take too much time on the acid base and salt. Okay. So guys, we learned about yesterday about crystallization in which the crystal is formed. And I request Ira and Edric to go and watch the video as quick as possible, and so that you can know about the crystallization process also. Okay, got it?
But
Now,
like in the group, there is a photo, no? Like that group, that photo
yeah,
can.
but in YouTube you can go and you can check the video. We have that video. So you can go and you can watch it out. And if you don't understand, then tomorrow we will discuss it on it. Okay. Okay. Did you understand? Yes or no? Now today what we will do? Today we will learn about the two processes. First one is um washing soda. Okay, I will make clear for you guys. Washing soda. So washing soda is basically Na2CO3 dot 10H2O dot 10H2O. Okay, this is the washing soda. So washing soda, like 10, dot 10H2O means basically the crystal form. Okay, it is
Sir,
also in the form of crystal.
sir,
And 10H2O, just give me a second, Edric. And 10H2O means the water is added in a molecule form. In which form? Molecule form. That is the meaning of this. Okay, 10H2 dot 10H2O means water is added into molecule form. Okay, Edric, yes, Edric, you were saying something.
sir, sir, but it's called sodium carbonate decahydrate.
Yes, decahydrate. Why? Because it's a crystal form. Like it, then water is added in a molecular form. Okay, it's form of crystal. Okay, so how we will make it? So we know that NaHCO3, which is baking soda or baking powder, when you will heat it, then what will happen? The sodium carbonate will form and carbon dioxide will release. Yesterday we learned this thing. Yes or no? This is the symbol of heat. Yesterday we learned that baking soda, when you will heat it, carbon dioxide will release. Now, when you will take this salt Na2CO3 and when you will add 10H2O in the formation of crystallization with the help of crystallization process, then you will get this Na2CO3 dot 10H2O.
Okay,
Did you understand, guys?
so what is triangle?
Triangle means heat.
I thought triangle means catalyst.
No, triangle means heat, and this NaHCO3 is basically baking soda or baking powder, anything that you want to take. Did you understand, guys?
Sir,
Yes or no?
but but sir,
Sir,
where did the H go? Where did the H go in the from the
Yeah,
reactant to the
H
product? Where did the H go?
H will become H2.
H2O. Okay. And NaHCO3 will become 2 NaHCO3. 2 NaHCO3.
Yeah, that we have to
Yeah.
check. Mid balance, you guys have to do it. Yes, Agatha.
sir, will you write all the formulas from the chemical bond in finally?
From the
Okay, in this chapter there are a lot and a lot of formulas. Will you finally write them all in one page so we can memorize them?
okay, okay. So I will do it, and then I will send it. Uh, uh, okay, if today in the end, if I will get time, then I will write it down. Okay, that's it. Okay. So this is how about washing soda. Now, what is the use of washing soda? You guys can read it from book. That washing soda is used for the uh, for for what? For cleaning and all, stain and all. You guys can read it from the book. Okay. Now the next, yes, Miracle.
Yeah, like I am thinking like how water is added in a molecule form, like how it can.
Yesterday I show you. Yesterday
Yeah,
I
yeah,
show you in
yeah.
a video. That is how we did it. Means boil it, then filter it, then the filtrate. We will boil it again. Put the ice bath. The crystal will form. That is how the crystallization occurs. Got it?
Yes,
No.
sir.
Miracle got it?
Yes, sir, I got.
Oh. Now this is the next salt is POP, which is plaster of Paris, CaSO4 dot half H2O. Okay,
Yes.
CaSO4 dot half H2O is called as POP,
POP.
plaster of Paris. Now, what is the use of plaster of Paris? So we have, like, if you will go and check the ceiling, if there is some design is there, it is made up of POP. Or if a medicinal use is also there for the POP, that if your hand is fractured, or to make the hand uh, in that same position so that the bone can join easily, we use POP, and to make, like, so the hand should be stable. Okay, so POP, which is called as plaster of Paris, okay, it is basically made up of gypsum, and gypsum is made up of plaster of Paris. Means that it is a cyclic process. How? See, the gypsum, if I will take gypsum, which is CaSO4 dot 2H2O, and if I will heat it at 373 Kelvin, then we will get POP, which is powder, like this. Okay, did you understand? And if you will, this is gypsum, and this is POP, which is plaster of Paris. And if you will take POP, which is CaSO4 dot half H2O plus 1.5 H2O, it will give us CaSO4 dot 2 H2O. Okay, then it is again become gypsum.
So
Okay,
wait, sir.
yeah, yeah.
So what is gypsum's formula, chemical formula?
Gypsum formula is this.
And then okay, so we just add gypsum with 2H2O.
Yeah, means molecular form 2H2.
Okay. Then we get the POP.
Yeah. No. Agatha. Gypsum formula is dot 2H2O, and when you will heat it at 373 Kelvin, then you will get POP. Okay.
So we
Now
heat
one.
gypsum with this two. So we heat gypsum and the 2H2O in 373 Kelvin to get the POP.
Yeah, and 1.5 H2O will be evaporate in the form of heat. Yes, Jashram.
So, what exactly do you do to the POP to get it into gypsum?
Like POP, we will simply add the water into it. Okay. Like the hard thing which is on the ceiling is basically now gypsum. It's not POP. Okay. It's
Okay.
gypsum. And when you will burn it at 373 Kelvin, it will become POP again. So it's a reverse cycle. Okay. POP burning, sorry, gypsum burning POP, POP adding water, gypsum. Yeah. Yes, Edric.
Okay. So, sir, basically, you know what? The gypsum is actually a harder version of POP.
Yes, a
And
harder version. Why? Because the water is added into it. Because water is added into it. That is why it's a harder.
how come you put 1.5 H2O over there? One and a-
It's a process basically. Adding water. Will not go in too much deep because it's not there in our course. Okay, so we'll
It's in
not go in
12th
too
course.
much deep. It's in 12 course. Yes. Anybody has any problem? Is my network is better? Or is everyone network is bad?
Only ours, sir. Our network is good.
Okay, okay.
CSO4 dot it. Okay. So In the first one, half H2O is a product, but in the second one, half H2O is a reactant. One and a half H2O. Sir,
Yes.
in the first equation, the one and a half H2O is a product, while the second reaction, one and a half H2O is a reactant.
Mm-hmm.
And also,
Just give me.
even though it's a chemical change, it is reversible.
Yeah.
Sir.
Yes.
Okay, so POP plus this 1/2 H2O can give us the POP by gypsum.
Yeah, we can do it. But it's a proper, we need proper condition for that. Like it should be 373 Kelvin only. If it is
So
more
should I
than
write
that, then it will
370 Kelvin?
373 Kelvin. Yes. If it is more than that, it won't it won't turn into POP and it will become dead gypsum or dead, or we can say burnt gypsum.
We have to heat it in P. We have to heat it. We have to heat these two substances together to get the final one, right?
Yes. Yes. Guys got it? No.
Yes, sir. Yes, sir.
Okay. Now we will start a new chapter, which is called as uh, what we call metal and non-metal. So everyone, you can start with a new page and name it as metal and non-metal.
What chapter? This is the 27th chapter.
Yeah, 27 chapter, which has metal and non-metal. Metal and non-metal. Okay, guys. Now everyone, please pay attention. Please pay attention. Okay. Now, metal and non-metal is basically we learned many a times. Okay. So for information or for revision again, we can understand it like metal. Metals, they are generally electron donor. Electron donor. They basically form cations. Every time they will form cations. Not every time, basically we can say. So I will take one example like Na. Na has an atomic number 11. Now in K shell, how many electrons will go? 2. In L shell, how many electrons will go? L. And in M shell, how many electrons will be there? 1. So for Na, it has two options: to take 7 electron or to give 1 electron. Now which one is easy for the Na? One to give 1 electrons. So Na will become Na plus 1 when he will give 1 electron. Now this Na plus 1, because it is electron donor, he gives the electron donor, hence it is called as metal. So metals generally are electron donor. Are you getting it? No.
Yes, sir.
Miraculin, you got it, beta? No, if you didn't understand, please ask me. I will help you.
I understood,
Got
sir.
it, beta? Okay. Now, second is non-metal. Non-metals. They are generally electron gainer. Electron gainer means they are basically they receive electrons. Hence, they are called as anion, because anions are those who have negative charge on it. Okay. So if I will talk about chlorine, chlorine has an atomic number 17. So in K shell 2 will go, in L shell 8 will go, in M shell 1 will go. So no, not 1, 7 will go. So it has two options: to take 1 electron or to give 7 electrons. So which one is easy for it? Miraculin, which one is easy for chlorine to take 1 electron or to give 7 electrons? You mute.
To gain 7 electrons.
To give
No.
7 electrons.
Gain.
To gain 9. It has two options. To gain 1 electron or to give 7 electron.
To gain 1 electron.
Yeah. So this one will not work. So basically, chlorine, when he will take 1 electron, he will get chlorine -1. So because the minus charge is there, it is called as anion. Hence, it's a non-metal. Hence, it's a non-metal. Got it, guys? Write it down quickly. And tomorrow there is probability of not having a class, but it's not confirmed yet. Okay.
Why, sir?
Okay.
Why, sir?
Because I have some work. But if it is happening with our class time, then I will inform it in the group that tomorrow is holiday. And if it is not allowing it, or if we can shift 20-15 minutes like forward, then I can say that we will have class at 10:30 or 10:40, whatever the best I can do. Okay.
Or
So I will
9:30
tell.
or 9:20.
No, before it is not possible. After is only possible. So I will tell it to you, like in at 9 or before 9, whatever the best time I will get. Okay. Okay, done.
Sir, I don't have the book, so I can't underline and write.
You don't have paper also? Paper, pencil, anything? You don't have?
Ah.
Edric,
you
where
have-
are you?
I'm in my native place, bro.
Oh, okay. And your
Okay,
native
so
place is Kerala?
okay, guys. Now listen. So we just know like how chemically metal and non-metal are, like what is the difference between them. Now we will learn about the physical property. Okay. So now please pay attention. So first point is malleable and ductility. Sorry. Now malleable is the property of heating with a hammer so that it can become a thin sheet. Okay. Malleable is a property in which when you will hit the substance into the form of with the help of hammer or with the help of hydraulic press, it will convert into a thin sheet. Now metal are malleable. They can be converted into a thin sheet when you will hit it with the hammer. But non-metals are non-malleable, means you will not hit it. For example, glass is non-metal. When you will hit it with the hammer, then what will happen? Like for example, on your door there is a glass, and when you will hit it with a hammer to check it's malleable or not malleable, then you will get hammer on your hand. Why? Because the glass will break. The glass will break, and if glass will break, then your bones will break. So basically, don't check it. Non-metals are basically non-malleable. Yeah, it means you can't make it into a thin sheet.
What does malleable mean?
Malleable means malleables means beating the substance to become a thin sheet. We have this definition. You can check that. Metals are malleable. Please check this. They can be beaten into thin sheet. They are also this is the basically meaning of malleable. Now the second property is ductility. Ductility means you can make a wire from it. So basically, all metals can be drawn into a wire except sodium and potassium. Okay, but non-metals are non-ductile, means you can't make it into a wire. Okay, malleability is the property of making into a thin sheet, and ductility is the property of making into a wire. So metals are malleable and ductile also, and non-metals are non-malleable and non-ductile. Got it, guys?
Yes, sir.
Yes or no?
Yes.
Okay. Now metal lustrous. So all metal has lustrous. Lustrous means what we say? Chamak. In yes, David.
So I was going to say that only.
Yes, please tell me.
So I was going to say what you said only.
No. Say.
So I was going to say that you asked. what
Otherwise,
is
otherwise you will
lustrous
get hurt. What is lustrous?
means. So shine.
Shine. Very good. Very good. So lustrous is basically the shine. So all metals are like they are shiny. Okay, but non-metals are not shiny. Okay, did you understand, guys? Now hardness. Hardness is basically all metals are hard, but we have exceptions. So you guys can write it down the exception with me on your book. The exceptions are sodium and potassium. They are not hard. They are soft.
Okay.
Okay.
So sodium and potassium are very reactive. Like they are not ductile and they are also not hard.
Yeah.
Then why are they called metals?
No, exceptions are there. Metals we called because of electrodonor. They all are electrodonor. I told you, na, those who have positive valency, they are electrodonor. But some properties they might not uh, have with the help of like as compared to other metals also. But the main concept of getting metal is electron donor.
Yes, sir.
Now non-metals are generally soft and as comparison to the metals, they are generally soft. Who non-metals are generally soft. Sonorous, sorry, physical state. Physical states are they are found in solid state, except like and liquid state also. In liquid state, you just write in front of it is mercury.
Mercury.
Mercury, which is the symbol is Hg. Okay, right in front of it Hg, which is mercury. It is in the liquid form.
Yes.
Okay. Now non-metals exist in solid, liquid, and gaseous form. So generally, all metals are in non-metals are in solid or gaseous form. But in liquid form, there is also one or two elements are there. First is bromine. Bromine. The name is Br. Okay. This bromine is basically in the liquid state. So you can write it down. Bromine as a liquid state.
So, sir, mercury is the only metal which can be found in its liquid state, and bromine
Yeah.
is the only non-metal which can be found in its
Not
liquid
only, not only, but one two metals are also there. But what we have to learn this thing because
Okay.
in the MCQ, they can ask like that odd one out: carbon, bromine, carbon, bromine, phosphorus, and sulfur. So out of this, what you have to select bromine. Why? Because bromine is in liquid state. That is the how
Then,
they can
sir,
ask.
what if they ask platinum, copper, gold, and mercury?
Mercury. So mercury will be the odd one out because it's in the liquid state. Otherwise, all are in a solid state. Now, sonorous, they generally have a sound of sonoricity. Sonorous means tongue, tongue, like that sound will come. Okay. And non-metals are generally non-sonorous. Now, high density, they have high density, they have low density. Electric conductivity, this is also most of the important thing. They all are good conductor of electricity except lead. Let me check if lead is the answer or not. Yes, lead. Lead. This is lead, TB. Okay. we have one more. It is called as bismuth. Bismuth. Okay. And mercury is also the example of exception of the good conductor of electricity. Okay. And bad conductor of electricity, yes, we have, but the exception is graphite. So, guys, you have to learn the exception. Okay, I am writing with you within your book. So please write. You guys also write it down. Okay, and write it down as a graphite as a exception part.
Then, sir, like,
Graphite conduct electricity. Yes,
then,
Achal.
since I am not there, can you like take a photo? Like, I don't have the book, so I can take photos.
So tell Jashan, take good photos. Jashan, take a photo, and when you send into the WhatsApp, there is an option of HD. So mark the HD one when you will send, na. So the picture which you will get, there is an option of HD. So mark that HD one also. Then you will get perfect picture. Got it?
Okay, I didn't see that yesterday, but I'll look for it today.
Yeah. And non-metals are generally soft, but it is also an exception. The exceptions are diamond. Diamond, which is made up of carbon, okay, it is not soft. It is very, very hard. More than metal also.
Sir, is diamond the hardest substance?
One of the hardest, we can say. Got it, guys? No, you didn't get it.
So then what would be the hardest substance? What would be the hardest
Hardest.
substance?
Yeah, I got it. Hardest substance. There is a one word from Q. Let me check it. Tungsten, cry. No. Yeah, naturally occur. Diamond is the hardest.
Yeah.
You guys check.
Naturally occurring is the hardest is diamond, but you know what? I've heard of some compounds containing boron also like being hard, but diamond is harder than those boron compounds. So,
Yeah. Correct. Done?
yes, sir.
Any problem, guys? If you didn't get it, so please ask me. Miracle.
Got it, sir.
Okay. Okay. Can you see this page clearly? Is it visible clearly? Okay. So we learn about the chemical properties of metal and non-metals. Like metals are generally cations. Okay, they are generally cations, cationic part, and non-metals are generally anionic part. This is called as anion, and this is called as cations. Okay, cations and anions. Okay, now reaction of metal with oxygen. Reaction of metal with oxygen. So we learned in the previous chapter also, but we will learn in this chapter also. Like
Sir,
when metals, yes.
Okay, so when metal react with oxygen, they'll form metal oxide.
Yeah. So first is reaction of, you guys can also write it down with me in the copy. Reaction of metal with oxygen. Okay. So whenever a metal react with oxygen, it will make metal oxide. Okay. What it will make? It will make metal oxide. So this metal oxide is basically, and we learned this metal oxide is basically what is in nature. Just now we learned in the acid base and salt. Agatha, Agatha, Agatha. Hello, hello. Metal oxide is in dash in nature.
It was, let me think, base. No, wait.
Yeah,
metal?
basic in nature. Metal oxide is basic in nature. I gave you the example, na? When I got when when bee loved me, the bee the bee when loved me on my hand, then my teacher gave me the metal oxide like key and rub it. So that metal oxide is basic in nature, children. Got it, guys? If you didn't get it, ask me, beta. Ira didn't get anything. Yes, Ira. Why?
No, sir, I understood.
Very good. Okay. So now what was I'm saying? That for example, if I will take one example, any metal, I will take Na plus oxygen, O2, when it will make. Now we will have to make compound like Na has a valency 1, O has a valency 2. You will cross multiply it, it will become Na2O. So this will become Na2O. Got it, guys? How we got it? No? Just not? Like if I will take Mg plus O2, so it will become MgO. How? Mg has a valency 2, O has a valency 2, both will cut, so it become MgO. This is how I got MgO and N2O. Okay? If I will take Al, aluminium plus oxygen, it will become
Al2O3.
Al2O3. How? Al is valency 3, O has valency 2. You will cross multiply it, it will become Al2O3. Got it, guys?
Then, sir,
Yes.
what? Okay. Now, okay, so you have sodium, magnesium, aluminum also. Like any metal can react with the oxygen. Even potassium, rubidium also can react.
Yeah, yeah, yes.
But gold can't.
Yeah, gold can't.
Gold can
I mean,
gold can only
it
react
takes
with
a lot of time. It can takes time, but yeah, gold and silver they do not react with, and platinum also they do not react with oxygen
like
because
gold.
they are nearly non-reactive.
Like gold can only react with like very very strong acid.
Yeah. So now the next topic is amphoteric oxide. Amphoteric oxide.
So you wrote acid.
Amphoteric. Huh?
So you wrote acid.
Amphoteric oxide. वो बंद करो पूरा. Amphoteric oxide. Amphoteric oxide. Now everyone please pay attention. See, amphoteric oxide is basically the oxide which do not have their identity. They are like those people who when I mean, it will be a little bit controversial. I will not say that. We can say, can I say that? I know it's a little bit controversial.
Yes, sir. Say it.
They are those people who come on church Sunday, and from Monday to Saturday they are in their club places. They are like those people. Got it? Means they will behave like good also, and they will behave like bad also. They don't have their own identity. Means Like if I will say about zinc oxide, if I will say zinc oxide, ZnO and Al2O3, they are basically the amphoteric oxide. Okay, amphoteric oxide. Everyone, please pay attention. Don't write it. I will give time to write this thing. Now, zinc oxide, when it will react with HCl, like this is metal oxide. Okay, and metal oxide is basically basic in nature. And basic in nature, when it is react with acid, okay, it will make salt and water, which is correct. Zinc chloride and water, H2O. This is salt and this is water, which is correct. But when zinc oxide react with NaOH, which is base, now they will behave like acid. Did you understand? So zinc oxide when react with base also, so they will behave like a acid. So it will become Na2ZnO2, which is called as sodium aluminate.
Zincate,
Wait,
zincate,
sir.
zincate, zincate.
Sodium zincate, sorry. Sodium zincate. Yes.
So is zinc basic or acid?
Zinc O, ZnO, it's basically metal oxide, and we learn metal oxide is basic in nature. So when they will react with acid, they will behave like a base. And when they react with acid, they will behave like a base. And when they react with base, they will react like acid. Okay, so they are like that people. So they will go to the church also, they will go to the nightclub also. That is that. Got it? Okay. Did you understand?
Zinc.
No.
What is zinc in? Zinc is amphoteric or the oxide given here.
Yeah, amphoteric oxide. Those oxide which behave. You can write the definition with me. Those oxide which behave. Those oxide which behave. Those oxide which behave acid when react with base. Those oxide which behave like acid when react with base, and base when react with acid. Base when react with acid. Guys, did you got it? No, you didn't get it.
Yes, sir. And, okay.
Same with aluminium also. Aluminium will also like amphoteric oxide. They will react with base. They will behave like a base when they react with acid. They will behave like acid when they react with base. Okay. Did you understand, guys? No.
Yes,
This
sir.
is
Just
little
write
bit
it
extra
down.
knowledge. This is extra knowledge because it's not there. I guess it's not there in your book.
Is there in the 12th standard book, I guess.
Yeah, but we should know this because question can, because it's in the CBSE part. So sometimes I mix the CBSE part also because it can come. We can't rely on NIS books also. Okay, so done. Did you understand? Okay, and guys, one thing I have to tell it to you guys that from March, it is possible that I can start 11th chemistry also. 11th class, like senior secondary chemistry also.
Bio?
So no, not bio, only chemistry subject. Like in 11th class, you can't take all three subjects and math also. As a teacher, you should take only one subject, which is you are like when you are imperfect in it. Okay, so that's why I can take only one subject, which is chemistry. So tell to your friends and relatives also, okay, that if they want to join for the senior secondary chemistry, they can join.
So is
Okay,
this
guys.
NIS base?
Yeah, NIS based only.
Only NIS base.
Then, sir, do you
The
take
first
classes
student
for
is ready.
sir? Do you take classes for CBSE also or only NIOS?
CBSE I will take offline.
That means
But
I have to go to Pali Road, Jodhpur, and then CBSE will
yeah,
come.
yeah. Okay. So just give me like you guys have 2 minutes break, then come back. We will have our like we will continue with the science class. Come back in 2 minutes.
Okay. Okay.
Edric,
Yes,
do you have a notebook with you?
I guess no.
So do I have to screenshot everything and send?
Yeah, like, or you can take like 2 or 3 screenshots instead.
Okay.
Okay, guys, come back. Okay. Now, the second topic is reaction of metal with acid. Reaction of metal with acid. So I will write here. The second one is reaction of metal with acid. So Agatha, we learned this in the previous chapter. Now you tell me. Everyone, come back. Yes, acid react with metal will make Agatha. Can you tell
Yeah.
me?
I don't know, maybe acidic.
Huh?
Acidic.
When acid react with metal, what is the answer of that?
Metal is mainly neutral or acid, right?
Okay, then
I guess acidic. Guess.
we learn now metal
Yeah,
salt
metal
plus
salt plus CO2 release. No, H2 release. Yeah.
no H2. H2 gas will release. That will give pop sound. We learn this. Agatha, what is you doing? Okay. So,
There were a lot of formulas.
huh?
There were a lot of
What?
formulas. There were a lot of formulas.
That we have to learn. That we have to learn. We when we learn this blue box, na, these types of things, na, then we will get easily. How? Like acid, if I will take HCl and if I will take metal like Na. So what will happen? Na will displace H from its compound, making NaCl and H2 gas will evolve. That will give pop sound when it will burn with oxygen. Okay, got it? No. Okay, any metal I can take. If I will take H2SO4, which is also acid, H2SO4 plus zinc, Zm. Okay, so what will happen? Zinc will uh, substitute from the H2, so it will become ZnSO4 plus H2 gas will release. Did you understand? Everyone turn your camera, Miracle and Edric. Okay, got it?
Got it.
Now, reaction of metals with water. Heading, put a heading. Reaction of metals with water. Now, reaction of metals with water. Before that, I want to teach you guys that reactivity series. Like we will learn this, and before that, we will learn about reactivity series. Edric, are you there? Yes, sir. No. I guess he's not there. Okay. Reactivity series is basically the series in which it is the metals are arranged in the form of decreasing reactivity. See, everyone, please pay attention. Then I will give right time because this is important. Everyone, please pay attention. David, everyone. Okay. Now, if I will write reactivity series, the first one is potassium. Or just give me a second. I will take the picture. Give me a second, guys. Reactivity. See, I am become digitalized. Okay, so you guys can check this. This is called as reactivity series. Can you see this?
Yes, sir.
This is reactivity series. Edit on the camera, beta. So in this reactivity series, you can see that potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, carbon, lead, hydrogen, copper, silver, gold. Now this is called as reactivity series. Everyone, please pay attention. You guys have to write it down, but first listen to me. Okay. Now reactivity series, the series in which the lower reactivity metal will, no, the higher reactivity metal will displace the lower reactivity metal from its compound. Okay, everyone, please pay attention. Agatha, pay attention. Here, please. Agatha. Yeah.
Yes.
Don't fight with sister. Just listen to me.
I am just
Okay.
discussing with her because she is just to study and she says she finished early. So I'm just telling her to study a bit more.
Yeah. But don't fight, okay? Okay, now listen. So now this is means that, for example, if I will take one compound, everyone please pay attention, okay? This is important, that's why I'm forcing. So if I will write FeSO4 plus zinc, FeSO4 plus zinc. Now zinc is more reactive, like zinc is coming in like above part than iron, na? So because it is more reactive, it can displace, like zinc can displace Fe from its compound, making ZnSO4 plus Fe. But if I will write ZnSO4 plus Fe, then like Fe is less reactive, so no reaction. It will be no reaction. So those compound who is less reactive from the metal, then it will not displace. But if it is more reactive, then it will displace. You got it, guys? No.
Like or you can put like potassium and sodium, like K and Na2SO4 will give K2SO4 and Na.
Yeah. So if I will take one example, everyone please pay attention. If I will write Cu plus FeSO4, so just run. What will be the reaction then? Cu
There
plus
won't be a
FeSO4.
reaction, right, sir?
Yeah, it won't be any reaction. Why? Because Cu is less reactive than Fe, which is in the compound. Got it, guys? Agatha, you got it?
So the less
No.
reactive elements should be in the should be after the most reactive sub elements to be reactive. I mean to be replaced.
Means?
Like
Means?
the first one, FeSO4. FeSO4 is iron and zinc is most reactive. So since the less reactive was first and the more reactive was next, there was a replacement. But in the next equation, the more reactive was first and the less reactive was less, so there was no reaction.
Yeah, so Fe will not able to displace it from a zinc. Okay, why? Because Fe is less reactive. It is like that. It is like that. We will take one example. There are two friends, okay, and the both friends are weak friends. Means they don't have any strength. Okay. Then the another one big bodybuilder came and he said, "Okay, you go from this guy. He's my friend now." So that's the weaker friend will say, "Okay, it's your friend because you are more powerful than me." Okay. Now this is one situation. That is the first reaction. The second reaction situation is there are two friends and they are bodybuilder type. Okay. Now weaker one will come and say, Please remove. He's my friend now." The bodybuilder will give a good nice slap to the weaker one. So there won't be any reaction. Like he won't be any successful. So this is how the second reaction works. The Fe is less reactive, less powerful, then it won't do any reaction. Got it? So this is called as reactivity series. Now, why we learn this? Why we learn this? Everyone, first write it down. Write it down, then I will teach you. वो गेट बंद कर दो, अभी ठंडा ठंडा हवा पास होता है, मेरा हालत खराब हो जाता है। मेरे को ऐसे पता पड़ेगा।
So more reactive will be no reaction or yes reaction.
Means, for example,
Like potassium and sodium.
so who is more powerful, potassium or sodium?
Potassium.
So potassium can displace sodium from its compound.
Okay. So the stronger one will always overtake the weaker one.
Perfecto.
Then why in Cu plus FeSO4, why in FeSO4 just overtakes Cu since he was stronger than SeFO4?
But Cu has to displace, na? FeSO4 is good with his friend SO4. The Cu has to displace, na? Cu is less weaker. Can you check this? Cu, this is, and this is Fe.
Yeah,
Cu
so why
has to
can't
displace.
so I can't Cu displace since FeSO4 is stronger than Cu.
No. The one who has to displace? Cu. Cu has to displace, na? FeSO from its compound. Okay.
Oh.
But CuSO4 is less reactive, na? You can check that CuSO4 is coming in the bottom of the table. It is
Yeah.
less reactive. So if it is less reactive, then Cu will not able to like remove Fe from its compound.
I'm saying that FeSO4 can replace Cu, right?
No. It won't. Like, for example, if I will take another example, like Fe plus CuSO4. Now, Fe is more powerful. Then Fe can displace CuSO4 from its compound, making FeSO4 plus Cu.
So now Cu is pure.
Cu is,
Pure.
what is pure?
It's a pure metal. There's no solution in it.
Yeah.
Okay. So like if a non-reactive metal has a salt solution and you want to get only the metal, then you can use a higher reactive metal to displace it.
Higher reactive metal we want, yes. Now listen, guys. Now one thing that everyone done till now? Everyone done? Agatha, David, everyone done?
Yeah.
Okay. Now reaction of metals with water. So basically in this, I guess there is no division in your book. Yeah, it's there, but it's not in clear form. Okay. So basically the metals react with water in 3 stages. 3 stages. The first one is if it is a cold water. The first one is when it is a cold water. So not all metals will react with cold water, okay, but only some of them. But only some of them will react with cold water. Not all metal. Now, who are that one? Those who are more reactive. Now, in the reactivity series, who are अरे हाँ वो खुल रहा है सॉरी
What's up?
नहीं वो जब भी आप बुलाना वापस okay so like not all the metals will react with cold water, only some metal, okay, like for example if I will talk about potassium, potassium which is K, and sodium which is Na. So they both will react with cold water. They are, because they are highly reactive, they can easily react with cold water. Okay, got it? No.
Yes, sir.
Okay, so like when these metal like Na, when react with cold water, it will give NaOH plus H2 gas will evolve. Now this NaOH is basically basic in nature. These are basically basic in nature. Who? NaOH. Got it? No.
Yes.
Okay. Okay. Now, basically, what is the reaction then? What is the reaction then? Whenever a metal react with water, whenever a metal react with water, it will form base and hydrogen gas will release. It will form base and hydrogen gas will release whenever a metal react with base. Now, as I told you, water can be in the three stages. First is cold water. So it means that if I will take iron and if I will put it into the cold water, will they react? No, they won't react. Okay. If I will take aluminium and if I will put into the cold water, will they react? No, they will not react. Okay. Did you
Why,
understand?
sir?
Huh?
Why won't they react?
Because they are less reactive. I
So
told
only
you.
the top one, potassium and sodium, can
Hmm,
only react.
can react with the cold water. Okay. Can react with the cold water.
Okay.
This is
Then what
first one is
about normal water and hot water?
we will learn cold water. And now we will come to the warm water. Warm water means lukewarm water. Okay. Lukewarm water. At lukewarm water, we can say that calcium calcium which is Ca and magnesium which is Mg, they can react. And the same thing will happen. How? Like for example, if I will take one example, like Ca plus H2. But the condition is it should be warm water. Cold water, it won't react. But warm water is there, then it will make CaOH whole twice 2 plus H2 gas will release. And this is called as slake lime that we learned in the acid and base formula. Got
The
it, guys? What I'm trying to say?
CaO
Huh?
is quicklime, while CaOH whole twice 2 is slakelime.
Correct.
So, sir, only
Hmm.
calcium and magnesium can only react in warm water.
Yeah, can react with warm water. Can react with warm water. Got it? No. Now, next one is steam. Next one is steam. Where is the black pen? Yeah. Now, next one is steam. So,
Sir,
in
not hot
steam,
water?
yeah, warm and hot, they all are similar. Okay, warm and hot, they all are similar. Now, we'll go to the steam.
How about
Okay.
neutral water?
Yeah.
Neutral water.
Yeah, cold, neutral, they come in one line. They are similar type. We can't specify, we can't make it like 2-degree water or 8-degree water or 9-degree water. No, they all are generally we are saying. Okay. Now in steam, basically we have aluminium, which is Al, and Fe, which is iron. They will react. Okay, they will react in steam. Okay, the same thing will
Only
happen.
two elements can only react with steam.
Yeah, not two elements. There are many elements. Like if I will check this, so we have zinc also, iron also. I think zinc will not react. Aluminium, iron. Yeah, I get. Let me check. Let me check. So first, aluminium plus water will make aluminium hydroxide, which is AlOH whole twice 3 plus H2 gas will react.
So then what about hot water?
Warm and hot are similar.
Okay, so the first two elements of the reactivity series react with cold water. The next two elements of the reactivity series react with warm water, and the next two uh, uh, elements of the reactivity series react with steam, right?
Hmm.
Then what about
Same
the
with
others?
zinc. Zinc, zinc. Uh-huh. The zinc will also react with steam,
Oh yeah, zinc also reacts the same because zinc is.
which is Zn. But
Then
other elements like copper, gold, silver, or we can say gold, copper, silver,
lead,
lead, platinum,
PT, platinum is PT.
platinum. Okay, this is called as lead. Copper is written by Cu. Gold is written by Au. Silver is written by Ag. Platinum is written by Pt. So these all are non-reactive with water, any type of water, steam, cold, or hot, any type of water. These are called as non-reactive with
What about lithium and beryllium? Where are they in the
form
reactivity series?
of water. What?
What about lithium and beryllium? Where are they?
Yeah, lithium and beryllium, they come under the warm water or normal water or cold water. So we will not go too deep in this. We will just learn that there are three types of waters are there: cold water, warm water, and steam. Cold water we have potassium and sodium. I guess lithium will also come in cold water, and then normal water beryllium will come. Warm water we have calcium, magnesium. Steam we have aluminium and iron and zinc. So they will react like this.
So
Take
lithium will come
screenshot,
in
okay?
cold water. So lithium will come in cold water and beryllium will come in warm water.
Maybe. Write it down quickly now.
Done, sir.
Everyone done? Ira, Agatha,
Yes, sir.
Ira done?
Yes, sir.
Okay. Now we will read this. Okay, which is corrosion. Okay, I will read this. Please pay attention on the board. As you know that the metals are react with air and form their oxides. These oxides formation tendency of metal affects the physical and chemical property. Can you guess one example in your day-to-day observation? You have already studied
Rustin
corrosion
of
in chapter number.
gate.
Huh?
Is it the rustin of gate?
Yeah.
Yeah,
Yeah,
rusting
like
of gate.
the rusting of iron, like
Yeah.
iron becomes iron oxide in the presence of water, moisture, oxygen,
Yeah.
air.
So you might have observed that the rusted nails at your home, rusted iron gate in your garden due to oxidation of iron. You just bring a rusted nail and a fresh nail. If you compare their physical property, you might have observed that the green layer over the old एक मिनट
So
नहीं 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 कुछ so you yeah you just bring a rusted nail and a fresh nail in. If you compare their physical property, you might have observed that the green layer of old copper coin, this green layer is due to the oxidation leading to the formation of copper oxide. So we learned that copper react with oxygen making copper oxide, which is finally converted into a basic copper carbonate on its surface due to the oxidation. All this process of the oxidation of metal is called as corrosion. So we learned that whenever a metal oxide is formed, it is called as corroded. Okay, whenever a metal oxide is formed, it is also called as corroded version of a metals. Okay,
So,
the
sir,
corrosion destruction of metal. Just give me a second. We will read it, then we will take your doubts. Corrosion leads to the destruction of metal surface by the action of air and moisture. Generally, the corrosion word is used for the oxidation of different metals. In case of corrosion of iron, we specifically term is rusting. So when an iron is corroded, it is called as rusting. Okay. When iron reacts with oxygen, it produces brown powder is called as rust. You can check the example. So this is like X is there. We have to balance it. You can guys balance it at home. Now rusting of iron, two important conditions are required: presence of moisture and presence of oxygen. If both are things are there, then iron will rust it easily. Yes. Now I will take it out.
it is clear, sir.
Sir,
Okay. Yeah.
why is there an X over there?
You have to balance it. You guys have to balance it.
I thought you can just put a 6 instead of an X and it'll become FeOH thrice. Whole thrice.
X. No. X you can put anything. If you will put 4, then 4H2O will be there. If you will take 10H2O, then it will become 10H2O. So more moisture, more oxygen is there, then the iron will become less, more weaker. Yes,
I
David.
think I think you can put 6 also. I think 6 is good.
Yes, David.
So, can anything corrode aluminium?
Also be corrodable, but it's required little bit condition.
I can't hear you. Edric, can you hear, sir?
Oh,
voice is
yeah.
not-
Can you hear me now?
Your voice is not clear, sir. We can hear you speaking, but your voice is not clear.
What can?
Hello, can you hear me now?
Yes, sir.
So what I was saying that aluminum can be rusted, but it requires little bit specific condition. Like you can't put like if you will put Na into the atmosphere, you don't require any energy. Like Na will automatically will make oxide. Same with potassium, they will automatically make oxide. But aluminum required little bit like more energy required to become oxide.
Okay.
Okay. Guys, got it?
Yes, sir.
Or, sir,
Any problem in today's class? No? No doubt? Okay, then we'll end this class. I hope you enjoyed the class. Till then, bye. Have a nice day. Sayonara.
Bye, sir.
Bye-bye.
Bye, sir. Thank you, sir.
bye,
Thank
sir.
you. Bye-bye.
Yes.
Bye-bye. Thank you.